What if humans were not the first civilization on Earth? Not the first to build cities. Not the first to reshape the atmosphere. Not the first to look at the planet beneath them and believe they had mastered it. What if, somewhere deep beneath our feet, locked inside ancient stone, there are traces of another intelligence that rose, transformed the world, and disappeared so completely that we no longer recognize its remains? Not towers, not machines, not roads, not bones arranged in museums, but something quieter. A thin layer of strange carbon in ancient rock, a sudden chemical scar in ocean sediment, a shift in atmospheric gases preserved in ice, a pattern that looks natural because too much time has passed for it to look like anything else. This is the question that makes deep time feel terrifying. Because when we think about lost civilizations, we imagine ruins, temples swallowed by jungle, cities buried beneath sand, broken statues, collapsed walls, tools, pottery, inscriptions, bones. We imagine archaeology as a search for recognizable things. But here's the problem. Earth is not kind to evidence. Given enough time, the planet destroys almost everything. Mountains rise and erode. Continents split and collide. Seafloors are born, dragged downward, melted and recycled. Ice sheets grind entire landscapes into powder. Rivers carry civilizations grain by grain into the sea. Even the oldest human monuments are young by geological standards. The pyramids are ancient to us, but to Earth, they are almost new, a blink, a scratch. A brief arrangement of stone that has barely begun its fight against time. Now imagine not 5,000 years. Imagine 5 million, 50 million, 200 million. What would remain? If an advanced civilization had existed long before humans, long before mammals ruled the land, perhaps even before the rise of the dinosaurs, would we actually find its cities? Or would we only find its shadow? Welcome to Whispers in Orbit, a place for slow, immersive journeys through the mysteries of space, time, and the hidden history of worlds. If you're drawn to questions that make the universe feel larger, older, and stranger than we usually dare to imagine, subscribe and keep drifting with us. Tonight, we are not leaving Earth, but in a way, we are going farther than we ever have before. Because the distance we are crossing is not measured in miles. It is measured in time. We are going downward into the layers of our planet, into ancient sediments and fossil gaps and mass extinctions, into the uncomfortable possibility that Earth's past may contain chapters we have mistaken for natural events simply because we never expected anything else to be there. The question is not easy, and it should not be answered carelessly. There is no confirmed evidence that an advanced civilization existed on Earth before humans. That matters. The responsible answer is not to pretend mystery is proof, but the question itself is real. Scientists have explored a version of it known as the Silurian Hypothesis, not as a claim that ancient industrial civilizations definitely existed, but as a thought experiment. If one had existed millions of years ago, what traces would it leave? And would we know how to recognize them? That is where the mystery begins. Because an advanced civilization may not leave behind the kind of evidence we expect. Buildings vanish. Metals corrode. Glass breaks down. Satellites fall. Coastlines move. Cities become sediment. But chemistry can last. Isotopes can last. Carbon ratios can last. Strange deposits can last. A sudden planetary disturbance can become part of the black record and remain there long after every name, language, and memory has disappeared. This is why the idea is so unsettling. If another industrial species existed deep in Earth's past, it might not be remembered as a civilization at all. It might be catalogued as an anomaly, a warming event, a chemical transition, a layer of unusual minerals, a mass extinction, a rapid change in ocean chemistry, a mystery that scientists debate for decades without ever suspecting that intelligence could have been involved. And that possibility turns the ground beneath us into something stranger. Every cliff face becomes a page. Every sediment layer becomes a sentence. Every extinction boundary becomes a pause in a story we may not fully understand. We have always told ourselves that human civilization is the first technological force Earth has ever produced, the first to dig carbon out of the ground and burn it into the sky, the first to alter global chemistry, the first to create materials nature did not make, the first to leave radioactive fingerprints, plastic fragments, industrial metals, artificial compounds, and climate signals that future geologists may one day recognize as unmistakably ours. But how do we know what unmistakable looks like after 100 million years? That is the uncomfortable question. Because our civilization is loud right now, it is visible from orbit. It glows at night. It moves minerals, burns fuels, changes forests, reroutes rivers, fills oceans with microplastics, and leaves traces in ice, coral, soil, and air. But geological time is patient. If humanity disappeared tomorrow, cities would not remain cities for long. Within centuries, vegetation would overtake roads. Within thousands of years, most buildings would collapse. Within millions, our greatest structures might be compressed, eroded, buried, or subducted. The Earth would begin converting us from history into chemistry. A future species might not find New York. It might find a layer, a strange, thin, worldwide layer enriched with carbon from fossil fuels, traces of plastics, altered nitrogen, industrial metals, and radioactive isotopes. To them, we might not look like people. We might look like an event. A sudden disturbance in the planet's system. A geological accident. That is the mirror this question holds up to us. When we ask whether another civilization existed before humans, we are also asking what we ourselves will become after enough time has passed. Will we be remembered as intelligence or as chemistry? The scale of deep time makes the question almost impossible to hold. Human history feels long because our lives are short. A century can contain revolutions, wars, empires, families, collapses, inventions, and entire worlds of memory. But Earth is about 4.5 billion years old. Complex life has existed for hundreds of millions of years. The dinosaurs ruled for far longer than humans have existed. The continents themselves have rearranged again and again. Against that background, human industrial civilization is not even a line. It is a spark. A few centuries of dramatic activity inside a planetary story, billions of years deep. If our technological phase lasted 10,000 years, it would still be almost invisible on a geological timeline. A brief pulse, a chemical flicker, a tiny disturbance that future scientists might easily miss, especially if they were not looking for technology in the first place. And that is the central danger of assumption. We tend to search for what we already believe should exist. If we believe humans were first, then ancient anomalies must be natural until proven otherwise. If we see a sudden carbon spike, we search for volcanoes. If we see mass extinction, we search for asteroid impacts, methane releases, ocean anoxia, climate shifts. And most of the time, that is exactly what we should do. Natural explanations are powerful. Earth is fully capable of catastrophe without intelligence. But the Silurian question asks something more subtle. Could a technological signature be hiding inside a natural-looking event? Not because scientists are blind, but because after millions of years, the difference between a natural disaster and a collapsed civilization may become dangerously hard to separate. Imagine a world before humans. A species rises somewhere on Earth. Perhaps not like us, perhaps not primates, perhaps not even mammals. It develops tools, industry, energy systems, maybe forms of technology that do not resemble ours. It alters its environment, grows, expands, reaches planetary scale, and then disappears. Maybe from climate collapse, maybe from war, maybe from resource exhaustion, maybe from something we cannot imagine because its biology, values, and technology were completely different from ours. The cities vanish first, then the machines, then the surface evidence. Eventually, only chemistry remains. Millions of years later, another intelligent species appears. Us. We dig into rocks and find strange patterns, but we do not call them ruins. We call them boundaries, anomalies, transitions, unexplained spikes, unresolved mysteries. And maybe that is all they are. Or maybe, hidden inside one of them is the last unreadable signature of a world that thought it would last forever. This is not a claim. It is a question. But it is one of the most haunting questions we can ask about Earth. Because it changes the planet from a familiar home into an archive with missing pages. A world that may have seen more than we know. A world whose deep past has been burned, buried, folded, drowned, and rewritten by time. And if there were others before us, the most terrifying part may not be that they existed. It may be that they vanished so completely. That should make us uneasy. Because we are also changing the atmosphere. We are also altering oceans. We are also leaving chemical signatures that may outlive our languages. We are also becoming part of the rock record. One day, if humans are gone, something may study the layer we left behind. And it may ask the same question. Was this nature or was this civilization? Tonight, we begin with that impossible uncertainty. We will explore what a vanished technological species might actually leave behind, why searching for cities may be the wrong approach, how geology preserves scars better than memories, and why the deepest evidence of intelligence may not look like intelligence at all. Because if humans were not the first civilization on Earth, the proof may not be waiting in ruins. It may already be beneath our feet, and we may have been walking over it our entire lives. If a civilization vanished from Earth millions of years ago, what would it leave behind? At first, the answer feels obvious. Ruins, machines, roads, bones, buried cities. Something recognizable. Something we could point to and say, this was built. But that answer belongs to human time, not geological time. Human time is measured in generations, monuments, records, and memory. A building that lasts 5,000 years feels ancient to us. A written text that survives 2,000 years feels almost miraculous. A bronze tool, a stone wall, a buried temple, these things seem like permanent evidence because they outlast individual lives, kingdoms, and languages. But Earth measures time differently. To Earth, 5,000 years is almost nothing. 10,000 years is a moment. 1,000,000 years is still not very long. And once you begin thinking in tens or hundreds of millions of years, the kinds of evidence we instinctively search for begin to disappear. Stone erodes. Metal oxidizes. Concrete fractures. Glass breaks, weathers, and becomes part of sediment. Cities collapse, then are buried, then compressed, then transformed. Coastlines move. Seafloors vanish into subduction zones. Mountains rise where oceans once were. The planet is not a museum. It is a machine. A slow, patient, grinding machine that recycles its surface, destroys context, folds evidence into rock, and turns the remains of entire landscapes into chemistry. So, if there had been another technological civilization before us, the first lesson is this: we should not expect to find it the way we find ancient human civilizations. We should not expect a city. We should expect a scar, a strange layer, a chemical imbalance, a sudden atmospheric shift, a pattern of isotopes, a material that appears too suddenly, spreads too widely, then vanishes, a brief planetary disturbance locked into stone. Because after enough time, civilization does not look like civilization anymore. It looks like geology, and that is where the trace would begin. Imagine humanity disappears tomorrow. Not gradually, not after a long decline, just gone. At first, the evidence would be everywhere. Cities would still stand, roads would still cut across continents, satellites would still circle Earth for a while, ships would rust in harbors, dams would hold back rivers until they failed. Airports, factories, mines, power plants, landfills, pipelines, data centers for centuries, maybe thousands of years in some cases. The technological layer of humanity would remain visible. But then the sorting begins. Rain enters cracks. Roots split foundations. Rivers change course. Oceans reclaim coasts. Wind buries roads beneath sand. Earthquakes break what engineering once held together. Ice advances and retreats. After 10,000 years, many surface traces would be damaged beyond recognition. After 100,000 years, only the most durable structures in the most favorable environments might remain. After 1,000,000 years, almost everything recognizable would be gone. And after 100 million years, a future intelligence might not find our towers. It might find a thin, strange layer in sediment. That layer would not say our names. It would not preserve our languages. It would not explain our dreams. But it might preserve what we did to the planet. That is the key. Civilizations may vanish physically, but planetary scale activity leaves planetary scale fingerprints. The most obvious fingerprint is carbon. Modern industrial civilization burns fossil fuels, ancient carbon, buried underground for millions of years, and releases it rapidly into the atmosphere. That carbon has a different isotopic character than carbon moving through ordinary surface cycles. It changes the ratio of carbon isotopes in the air, oceans, soils, and organisms. A future geologist might not know our politics, our art, or our myths, but they could identify a sudden injection of old carbon into the active Earth system. To them, it might appear as a spike, a sharp disturbance in the carbon record. Something happened here, the rock would say. Something released buried carbon very quickly. The natural world can do this too. Massive volcanism can release carbon. Methane hydrates can destabilize. Organic carbon can be oxidized. Climate feedbacks can amplify changes. Earth has many ways to create dramatic carbon events without technology. That is why caution matters. A carbon spike alone does not prove civilization. But it is exactly the kind of trace we would look for. Not a monument, a disruption. Something brief, global, and chemically unusual. Then there are oxygen levels, nitrogen cycles, sulfur chemistry, ocean acidity, and metal concentrations. An industrial society does not merely burn fuel, It mines, smelts, refines, manufactures, fertilizes, transports, and discards. It moves elements from one place to another at scales natural processes do not usually imitate in the same way. Lead, mercury, chromium, nickel, rare earth elements, the signatures of extraction and industry, can enter sediments, river deltas, ocean basins, and soils. Over short time spans, these signals can be obvious. Over millions of years, they become more ambiguous. A layer rich in unusual metals might be industrial pollution, or volcanic ash, or an impact deposit, or hydrothermal activity, or a concentration created later by fluids moving through rock. This is the central difficulty. The deeper into time we go, the more evidence loses its original shape. A factory becomes metal enrichment. A city becomes rubble, then sediment. A power grid becomes nothing. A plastic bottle becomes fragments, then chemical residue. A nuclear test becomes isotope ratios. The world forgets the form and keeps the chemistry. That is why isotope signatures matter so much in this question. Isotopes are versions of the same element with different numbers of neutrons. They behave similarly chemically, but their ratios can reveal processes that created or separated them. Biology leaves isotopic fingerprints. Volcanism leaves fingerprints. Climate change leaves fingerprints. Nuclear reactions leave fingerprints. In our own age, nuclear technology has created isotopes that were extremely rare or absent in natural surface environments before humans. Some decay quickly. Others persist much longer. Future scientists, if they sampled the right layers, might identify a brief global signal of artificial radionuclides associated with the nuclear age. The trace would be thin, but unmistakable if preserved. Now imagine a civilization millions of years before us that also mastered nuclear processes. Would we find its reactors? Probably not. Would we find its weapons? Almost certainly not. But might we find an unusual isotopic anomaly preserved in sediments, minerals, or ice-equivalent archives? Possibly. The problem is interpretation. Because nature can also produce nuclear signatures under rare conditions, natural nuclear reactors did occur on Earth in the deep past, when uranium deposits and groundwater conditions allowed sustained fission reactions. So even nuclear-like traces must be handled carefully. A strange isotope pattern might point to technology, or it might point to an unusual natural reactor, an impact event, cosmic ray exposure, or some geological process we do not yet fully understand. This is why the search is so difficult. The evidence we would expect from an ancient civilization overlaps with evidence from natural catastrophe. Both can alter climate. Both can change oceans. Both can create mass die-offs. Both can concentrate metals. Both can leave isotopic scars. Both can appear suddenly in the rock record. And after enough time, context becomes damaged. That is the terrifying part. Not that we have clear proof of a lost civilization. We do not. The terrifying part is that if such proof were subtle enough, old enough, and mixed with natural planetary processes, it might not announce itself as proof at all. It might sit inside a database as an anomaly, a curious layer, a paper with cautious language, a possible natural explanation, a signal nobody connects to intelligence because the idea feels too strange to consider. Now think about synthetic materials. Our civilization has created substances that nature did not produce in the same way before us. Plastics, industrial polymers, complex manufactured compounds, long-lived chemical residues. Some will degrade, some will fragment, some will transform, but microscopic traces may persist in sediments, especially in low oxygen environments like deep ocean basins. If future geologists find a sudden global layer rich in microplastics, they will know something unusual happened. But would plastic survive for millions of years? That depends. Many would break down. Some might alter chemically. Some might become part of new mineral-like residues. Others might be destroyed by heat, pressure, or microbial activity. In the deepest future, the evidence may no longer look like plastic at all. It may look like strange carbon-rich particles, unusual additives, abnormal chlorine compounds, or peculiar distributions of hydrocarbons. Again, the form disappears. The signal mutates. A civilization's trash becomes geochemistry. And this is where the question becomes almost eerie. If a previous civilization used materials different from ours, biodegradable composites, ceramics beyond our current technology, engineered minerals, organic electronics, biological manufacturing systems, what would remain? Maybe not the materials themselves. Maybe only the side effects. A sudden spread of rare catalysts, unusual synthetic organics, a layer of microscopic spheres from high-temperature processes, a mismatch between what the environment should have produced and what the sediment actually contains. The trace might be too unfamiliar to interpret. We are biased toward our own technology. We know how to recognize fossil fuels, plastics, concrete, aluminum, nuclear isotopes, industrial metals, and combustion products because those are our fingerprints. But a different civilization may not leave the same ones. If it used energy cleanly, built with materials that degraded fully, or lived mostly underwater or underground, its visible signature could be far weaker than ours. Or stranger, a truly advanced civilization might leave less obvious evidence, not more. That idea is unsettling because we often imagine technology as increasingly visible. Larger cities, more machines, more pollution, more satellites, more light. But perhaps the most advanced technological systems would become more integrated, more efficient, more subtle. A civilization that mastered sustainability might avoid leaving the loud scars we are leaving now. It might be almost invisible. Unless something went wrong, collapse might leave the clearest record. A rapid carbon release, a sudden extinction, a chemical imbalance, a brief radioactive layer, a strange deposit of engineered material followed by silence. Civilizations may be easiest to detect at the moment they fail. That is a dark thought. It means the geological record might preserve catastrophe better than success. A stable civilization that lived carefully for hundreds of thousands of years might be harder to detect than a reckless one that burned itself into the rocks in a few centuries. And if that is true, then our own detectability may be a warning. We are becoming visible to the future because we are disturbing the planet, not because we are wise. This is why the trace left behind is not just a scientific question, it is a mirror. What will future Earth remember of us? Not our music, not our languages, not the names of our nations, not the stories we told about ourselves. At geological distance, Earth may remember us as a carbon excursion, a plastic horizon, a pulse of extinction, a rearrangement of nitrogen, a layer of radionuclides, a sudden movement of metals, a brief and violent disturbance in the chemistry of a planet. We may become readable only as damage, and that possibility should make us pause before imagining lost civilizations too easily. Because if we search the past for others like us, we may not be searching for glory. We may be searching for scars. In the next part, we will move deeper into the idea behind this question, the Silurian Hypothesis. We will ask why scientists proposed it, why ruins may be the wrong thing to look for, and why the most important evidence of a vanished industrial species might already be in front of us, hidden not by secrecy, but by assumption. Because perhaps the hardest part is not finding the signal. Perhaps the hardest part is believing that a signal could be there at all. The idea sounds impossible at first. A civilization before humans. Not ancient humans. Not a lost city beneath the sea. Not some forgotten culture from 10,000 years ago. Something far older. Something that could have risen millions of years before us, changed the planet, and vanished so completely that no statue, no wall, no machine, no language, and no memory survived. This is the heart of the Silurian Hypothesis. It does not begin by claiming that such a civilization existed. That distinction matters. It begins with a question. If an industrial civilization had existed on Earth long before humans, would we be able to detect it? And that question is far more disturbing than it first appears. Because the longer you think about it, the more you realize that our expectations may be wrong from the beginning. We imagine evidence in human terms. We imagine a buried city, a metal artifact, a tunnel, a monument, a skeleton holding a tool, something dramatic enough to force the entire world to stop and look. But an ancient industrial civilization may not leave behind a dramatic object. It may leave behind a pattern, a chemical shift, a strange isotope ratio, a sudden warming event, a layer of unusual sediment, a mass extinction boundary, a planetary disturbance that we have already named as natural because we never expected intelligence to be part of the story. That is why the Silurian Hypothesis is so unsettling. It asks us to stop searching only for things that look like civilization and start asking what civilization becomes after geological time has erased its shape. A city is temporary. A chemical scar can last much longer. Think about our own world. Right now, humanity is visible everywhere. At night, our cities glow from orbit. Our roads cut across continents. Our ships cross the oceans. Our satellites circle the planet. Our mines open wounds in mountains. Our farms reshape ecosystems. Our factories move elements from underground reservoirs into the atmosphere, rivers, oceans, and living bodies. We are impossible to miss. But that is because we are happening now. From inside the event, civilization looks permanent. From deep time, it may be almost invisible. If human civilization disappeared, the Earth would begin editing us immediately. The lights would go out first. Satellites would fail. Buildings would decay. Roads would crack. Forests would return where they could. Dams would collapse. Coastal cities would drown or erode. Steel would rust. Concrete would crumble. Glass would fracture and weather. Plastics would fragment, alter, sink, burn, or become buried in sediment. Give the planet 10 million years, and almost nothing would remain in a form we would recognize. Give it 100 million years, and even less. A future intelligence might not find our airports, data centers, or skyscrapers. It might find a boundary layer, a thin, odd, global disturbance in the rocks. To them, we might appear not as people, but as an event. That is the shift the Silurian Hypothesis forces on us. It asks whether civilization is the wrong thing to search for. Perhaps the better question is, what does technological activity look like after the planet has digested it? The answer is not simple. The Earth's crust is active. Ocean floor is recycled through plate tectonics. Sediments are buried, compressed, heated, folded, uplifted, and eroded. Rocks are transformed through metamorphism. The older the evidence, the less surface area remains unchanged. Much of what once existed has been destroyed not by conspiracy, but by geology. This alone makes the search deeply difficult. A civilization that lived mostly on coastlines would be especially vulnerable to erasure. Coasts move constantly. Sea levels rise and fall. Continental shelves flood and dry again. Storms, waves, rivers, and sediment flows grind evidence down. And human civilization today is heavily coastal. Many of our largest cities sit near oceans and rivers, exactly the places most likely to be reworked over geological time. If another species had done the same, its most important centers might now be seabed, sediment, or nothing at all. A civilization that lived on land would fare only slightly better. Mountains erode, deserts shift, glaciers scrape landscapes clean, volcanism buries regions under new rock, faults fracture and displace the ground. A city preserved in perfect condition for millions of years would require extraordinary luck. Not impossible, perhaps, but extremely unlikely. And this is why the hypothesis does not focus on ruins. It focuses on signatures. The first possible signature is energy use. Every civilization must power itself somehow. It may burn carbon. It may split atoms. It may harvest sunlight at enormous scale. It may use geothermal heat, tidal systems, biological systems, or energy technologies we have not imagined. But energy use at planetary scale tends to alter the environment. If a civilization burns fossil carbon, it changes atmospheric carbon dioxide and carbon isotope ratios. If it relies on large-scale agriculture, it changes nitrogen and phosphorus cycles. If it smelts metals, it enriches sediments with unusual industrial elements. If it develops nuclear technology, it may create isotopic patterns distinct from most natural processes. If it manufactures synthetic compounds, some chemical residues may persist. Not forever in their original form, but long enough, perhaps, to become geological clues. The second possible signature is climate disturbance. Modern humanity is already leaving such a signal. Carbon dioxide is rising rapidly. Methane has changed. Global temperatures are shifting. Oceans are absorbing heat and carbon. Ice is melting. Sea level is responding. The biosphere is changing under pressure from land use, pollution, extinction, and industrial activity. To future geologists, the present may appear as a sharp disruption, not because they know our story, but because the planet's systems suddenly changed. If an ancient civilization caused similar disruption, we might see something like that in old rock layers: a rapid carbon excursion, ocean acidification, oxygen changes, unusual warming, altered sedimentation, extinction patterns, and then recovery over time. The difficulty is that Earth can produce these signatures naturally. Massive volcanism can release enormous amounts of carbon. Methane can be destabilized. Asteroid impacts can ignite global fires, throw dust into the atmosphere, and disrupt climate. Ocean circulation can collapse. Biological innovations can transform the atmosphere, as photosynthesis once did. Natural feedback loops can create sudden changes that look almost engineered in their speed and scale. This is the problem at the center of the Silurian Hypothesis. The signatures we would expect from a lost industrial civilization may resemble the signatures of natural catastrophe, and after millions of years, separating the two becomes brutally hard. A carbon spike could be industry, or volcanism. A metal anomaly could be manufacturing, or an impact layer. An extinction could be ecological collapse caused by technology, or a natural planetary crisis. A strange chemical deposit could be synthetic, or simply a rare geological process we do not yet understand. The hypothesis does not give us an easy answer. It gives us discomfort. It tells us that if we want to search for a prior civilization, we cannot rely on a single clue. We would need a pattern of evidence, multiple signals appearing together in ways that are difficult to explain naturally. A rapid carbon shift, unusual isotope ratios, sediment changes, industrial metals, possible synthetic residues, extinction pressure, ocean chemistry disruption, maybe even signs of energy use that do not match known natural mechanisms. One clue can mislead. Many clues, aligned in time and distributed globally, would be harder to dismiss. But even then, caution would remain essential, because Earth is complex enough to imitate mystery. That may be the most humbling part. We often imagine that if a previous civilization existed, proof would be obvious. But the Silurian hypothesis suggests the opposite. The evidence might be subtle, ambiguous, and deeply dependent on interpretation. It might require us to recognize a technological pattern without any surviving technology. That is like trying to identify a vanished person from a footprint after the rain has almost washed it away. Possible, perhaps, but never simple. There is another unsettling possibility. What if a previous civilization was more sustainable than ours? We tend to assume advanced civilizations become more visible over time. Larger cities, more energy use, more pollution, more machines, more waste. But perhaps that assumption says more about us than about intelligence in general. A civilization that mastered long-term survival might minimize its geological footprint. It might use renewable energy. It might build with materials that biodegrade or return cleanly to natural cycles. It might avoid massive carbon release. It might keep population and consumption within planetary limits. It might integrate technology into ecosystems so smoothly that after enough time, it becomes nearly indistinguishable from nature. If such a civilization existed and succeeded for a long time, it might be harder to detect than a reckless one that collapsed quickly. That is a deeply uncomfortable thought. Failure leaves scars. Wisdom may leave almost nothing. So if we look into the rock record, searching only for dramatic disturbances, we may be biased towards civilizations that destroyed themselves. And if we find nothing obvious, that does not necessarily prove nothing existed. It may only mean that nothing catastrophic enough was preserved. But the reverse is also true. If we find a dramatic disturbance, it does not prove civilization. It may only prove Earth is dangerous. This is why the Silurian hypothesis lives in a strange space between science and imagination. It is not evidence of a lost species. It is a test of our assumptions. A way of asking how durable technology really is, how readable geological history really is, and how confident we should be when we say we are the first. That word, first, carries more weight than we realize. Humans like being first. The first toolmakers. The first industrial species. The first minds to look at Earth from space. The first beings here to change the planet consciously, dangerously, and globally. But Earth is old enough to make human certainty feel fragile. The planet had billions of years before us. Entire worlds of life rose and vanished. Continents changed shape. Oceans opened and closed. Atmospheres transformed. Ice ages came and went. Asteroids struck. Volcanoes remade climates. Species dominated for spans far longer than our entire lineage has existed. In that immense past, could intelligence have emerged once before? not necessarily human-like, not necessarily mammalian, not necessarily land-based. It could have been marine. It could have been biologically strange. It could have used materials that do not preserve well. It could have flourished in environments that are now gone. It could have been advanced enough to change the planet, but not durable enough to escape time. Again, there is no confirmed proof, but the possibility alone changes how we look at the rocks. The fossil record becomes less like a complete history and more like a damaged archive. The absence of evidence becomes less comforting. Not because we should believe every anomaly is artificial, but because we recognize how much is missing. We are reading Earth through fragments, and fragments encourage humility. The Silurian Hypothesis also turns our attention forward. Because if a civilization before us could vanish into geology, then so could we. This is the mirror again. We are leaving traces that future beings may study. We are creating a global layer of artificial materials, altered carbon, metals, nitrates, radionuclides, and extinction pressures. But whether those future beings recognize our layer as civilization may depend on what survives and what they believe is possible. If they assume they were first, they may explain us away. They may call us a climate anomaly, a mass extinction pulse, a peculiar carbon event, a strange plastic-like horizon. They may debate whether some natural process caused the disturbance. They may never imagine the traffic, music, grief, ambition, and ordinary lives hidden behind the chemistry. That is perhaps the most haunting part of all. A civilization can be real and still become unreadable. It can have language, memory, love, fear, science, art, and machines, and after enough time, all of that can collapse into a thin, ambiguous signature in stone. The Silurian Hypothesis asks whether that may have happened before, but it also asks whether that is what we are becoming. In the next part, we will move into the strange patterns in Earth's past fossil gaps, mass extinctions, sudden climate shifts, atmospheric transformations, and chemical disturbances that stretch across the planet. We will not treat them as proof of lost civilizations, but we will look at them through the unsettling lens this hypothesis provides. Because once you understand what a vanished civilization might leave behind, the next question becomes harder to ignore. How many ancient scars have we already seen without knowing what we were looking at? Once you understand what a vanished civilization might leave behind, Earth's history begins to feel different. Not because every mystery becomes evidence. It doesn't. Not because every extinction hides technology. It almost certainly doesn't. But because the deep past stops feeling complete, it becomes less like a finished book and more like a damaged archive, where some pages are burned, some are missing, and some are written in a language we are still learning how to read. That is where the strange patterns begin. The fossil record is not a smooth story. It does not show life rising in a clean, gradual line, from simplicity to complexity, from ocean to land, from small to large, from primitive to advanced. It is broken, uneven, interrupted. Long periods of relative stability are suddenly shattered by extinction. Entire ecosystems vanish. New forms appear. The atmosphere changes. Oceans reorganize. Climate swings from greenhouse heat to deep cold and back again. Most of these events have natural explanations. Asteroids strike. Volcanoes erupt. Oceans lose oxygen. Climate systems tip. Continents move. Species fail. Earth is fully capable of catastrophe without help. But here's the problem. Some of the patterns are so large, so sudden, and so global that they force us to ask uncomfortable questions about what a planetary disturbance actually looks like. And if a technological civilization had once altered the planet, the evidence might resemble exactly this kind of disturbance. Not a city, a transition. Not a machine, a scar. Start with the most famous boundary in Earth's recent deep past, the end of the dinosaurs. Around 66 million years ago, something changed almost everything. A massive asteroid struck near what is now the Yucatan Peninsula, releasing energy beyond human imagination. Dust and aerosols entered the atmosphere. Sunlight was reduced. Food chains collapsed. Many species disappeared. The non-avian dinosaurs, after dominating Earth for more than 150 million years, were gone. That event is not mysterious in the way it once was. The evidence is strong. The crater, the global layer of unusual elements, shocked minerals, tsunami deposits, and the sudden biological turnover. It is one of the clearest examples of a planetary catastrophe preserved in stone. But for our question, the important lesson is not that an asteroid killed the dinosaurs. The important lesson is that Earth can remember a single catastrophic event for tens of millions of years. Not perfectly, not emotionally, not with names or witnesses, but chemically. A thin boundary layer can outlast continents of living beings. That should make us pause. Because if a natural event can leave a global signature that survives for 66 million years, then a technological event might also leave one if it were large enough, sudden enough, and chemically distinct enough. But recognizing it would be difficult. Imagine a future geologist finding our layer. They might see a carbon isotope shift, a sudden rise in greenhouse gases, plastics or altered organic residues, artificial radionuclides, changes in pollen, species loss, heavy metals. Nitrogen disruption, a worldwide signal compressed into a thin boundary. They would know something happened. But would they know it was us? Or would they search first for volcanoes, impacts, methane releases, ocean chemistry, and climate feedbacks? They should search for those things. That is how science works. But the uncomfortable possibility remains. A civilization, after enough time, may look like a natural disaster until proven otherwise. Now consider mass extinctions. Earth has suffered several major extinction events, each reshaping the direction of life. The Ordovician-Silurian extinction, the late Devonian crises, the Permian-Triassic extinction, the Triassic-Jurassic extinction, the Cretaceous-Paleogene extinction. Each one is different. Some seem tied to climate change, some to ocean anoxia, some to volcanism. One clearly involves a large asteroid impact. Some remain debated. But together, they reveal a disturbing pattern. Life on Earth is not secure. It can flourish for millions of years, then be cut down by planetary forces too large for any species to resist. The most severe of all was the Permian-Triassic extinction, often called the Great Dying. Around 252 million years ago, the majority of marine species vanished, along with many land species. The world appears to have undergone catastrophic warming, ocean oxygen loss, acidification, ecosystem collapse, and massive disruption to the carbon cycle. The leading natural explanation involves enormous volcanic activity in what is now Siberia, releasing vast quantities of gases into the atmosphere and triggering cascading environmental failure. That explanation is powerful, but the event itself still feels almost unreal. Carbon changes sharply, ecosystems collapse globally, oceans become hostile, recovery takes millions of years. If you were looking for the geological trace of a civilization that burned through its energy base and destabilized the planet, you might expect some of the same broad symptoms: rapid greenhouse gas increase, ocean stress, extinction, and long recovery. That does not mean the Great Dying was artificial. It means the signature of industrial collapse and the signature of natural climate catastrophe may overlap in unsettling ways. And that is the central tension. The past contains events that look, in outline, like planetary scale disruption. But outline is not proof. A volcano can imitate industry. An asteroid can imitate war. A methane release can imitate fossil fuel combustion. A natural extinction can imitate ecological collapse caused by intelligence. The evidence becomes a problem of discrimination. How do you tell the difference between a planet harming itself through natural feedbacks and a civilization harming it through technology? You need details. The timing, the isotope ratios, the distribution of metals, the presence or absence of synthetic compounds, the structure of sediments, the biological response, the rate of change, the global pattern, and even then, certainty may remain out of reach. That is what makes the question haunting rather than simple. Earth's past is not empty of strange transitions. The Great Oxygenation Event, over 2 billion years ago, transformed the atmosphere by increasing oxygen levels. To modern life, oxygen is essential. To much of the microbial life that existed before, it was toxic. The rise of oxygen was one of the most important environmental revolutions in Earth's history. It changed chemistry, climate, metabolism, and the future direction of life. The standard explanation is biological. Photosynthetic microorganisms produced oxygen, and eventually, that oxygen accumulated faster than Earth's rocks and oceans could absorb it. No civilization is needed. And yet, from the distance of deep time, the event has the shape of planetary engineering. A world's atmosphere changes. Many organisms die. New forms of metabolism become possible. The chemistry of the planet is rewritten. Again, the responsible conclusion is natural biology. But the emotional lesson remains. Earth's atmosphere can be transformed by life itself. Biology can become a planetary force. Life can alter the air so deeply that future life is forced to evolve inside the world it created. Humans are doing something similar now, though through industry rather than photosynthesis. That connection is uncomfortable. It means intelligence is not the only thing capable of planetary transformation. Life itself can do it. Microbes did it. Plants did it. Humans are doing it. A prior civilization, if it existed, might have done it too. The challenge is telling which transformation belongs to which cause. Then there are fossil gaps. The fossil record preserves only a tiny fraction of all organisms that ever lived. Most bodies decay. Most environments do not fossilize well. Soft tissues vanish. Erosion destroys layers. Metamorphism alters rocks. Plate tectonics recycles crust. The record is biased toward hard parts, favorable burial, and geological luck. So gaps are expected. But gaps still shape how we imagine life's history. The Cambrian explosion, more than 500 million years ago, is one of the most famous examples. In a relatively short geological interval, many major animal body plans appear in the fossil record. Eyes, shells, limbs, predators, burrowing organisms, complex ecosystems. Life seems to become visibly more elaborate very quickly. There are serious natural explanations: rising oxygen, ecological arms races, developmental genetics, better fossil preservation, environmental changes. The Cambrian explosion is not evidence of technology, but it demonstrates something important. The fossil record can make transitions look abrupt, especially when preservation changes or biological systems cross thresholds. That matters for the Silurian question, because an ancient civilization's biological effects might not appear as tools or cities. They might appear as ecological discontinuity, a sudden decline of certain organisms, a burst of new adaptations. unusual extinction selectivity, a shift in trace fossils, changes in reefs, forests, soils, or plankton, a biosphere reorganizing around new pressures. But once again, nature can do this too. Predators evolve, oxygen rises, climate shifts, continents move, sea levels change, organisms invade new niches, ecosystems reorganize without intelligence guiding them. So the question is never, is this strange? Earth is strange by default. The better question is this strange in a way that natural mechanisms cannot explain? And for now, when it comes to ancient, pre-human civilizations, we do not have that kind of evidence. But we do have a reason to remain humble. Because Earth repeatedly shows us that the planet is capable of abrupt change, incomplete preservation, and deep ambiguity. There are warming events, like the Paleocene-Eocene thermal maximum around 56 million years ago, when global temperatures rose significantly and the carbon cycle shifted sharply. The leading explanations involve natural carbon release, perhaps from volcanism, methane hydrates, or other feedbacks. It is studied today partly because it provides a natural comparison to rapid carbon release in our own era. Again, not proof of civilization, but as a pattern, it is exactly the sort of event the Silurian Hypothesis tells us to examine carefully. A rapid carbon injection, climate disruption, ocean changes, and recovery over long time spans. If humans vanished and our industrial carbon pulse were studied millions of years from now, it might appear in a similar category of geological disturbance. That is the mirror we cannot escape. The past looks strange because Earth is dynamic. The future may find us strange for the same reason. Now imagine a scientist millions of years from now studying the Anthropocene, if that term survives in any form. They might see a sudden spike in carbon dioxide, a rapid extinction pulse, artificial compounds if preserved, changes in sediment from agriculture and construction, radioactive traces from nuclear activity, metals redistributed across the globe, microplastic residues, or their altered chemical descendants, a narrow layer of disturbance, then perhaps silence. Would they call it civilization? Or would they call it a rapid environmental anomaly? That depends on what survives and on what they believe is possible. This is why assumptions matter so much. If a future species has never seen an industrial civilization before, they may not interpret the signal correctly. If they assume intelligence leaves monuments, they may miss chemistry. If they assume technology must resemble their own, they may misread ours. If they believe they are the first, they may explain us away as natural. The same may be true of us looking backward. We may be too confident in our categories: natural, artificial, biological, industrial, accidental, designed. After enough time, these categories blur. A natural process can create a signal that looks organized. An artificial process can degrade into a signal that looks natural. A civilization can vanish into the same kinds of sediment that preserve volcanic ash, impact debris, and ocean anoxia. The rock record does not label its causes. It only preserves effects. And this is where the scale becomes uncomfortable. Human beings have existed for only a tiny fraction of Earth's history. Industrial civilization is younger still. We are trying to interpret billions of years of planetary change from fragments that survived destruction by accident. We are clever, but we are not omniscient. Our tools are powerful, but the archive is damaged. Our models are improving, but Earth remains older, larger, and more complicated than our certainty. That does not mean we should fill gaps with fantasy. It means we should treat gaps as gaps. Unknown does not mean artificial. But unknown also does not mean understood. Between those two errors lies the narrow, honest path. The Silurian lens does not ask us to believe every anomaly is a hidden civilization. It asks us to recognize how hard the question would be to answer if the civilization were old enough. The strange patterns in Earth's past may be natural. Most probably are. But they still teach us what planetary scale disturbances look like. They show us how chemistry can change globally, how life can collapse and recover, how atmospheres can transform, how oceans can become hostile, how sudden events can leave thin but lasting scars. And if an ancient technological species ever did rise and fall before us, its final trace would likely belong to this same family of evidence. A layer, a shift, a scar. Something small enough to miss, but large enough to change a planet. In the next part, we face the most terrifying problem directly. After enough time, even a powerful civilization could almost completely disappear. Not because it was weak, not because it never mattered, but because Earth is too old, too active, and too good at erasing its own surface. And that raises the question at the heart of the entire mystery. How much of Earth's history have we truly read, and how much have we simply mistaken for silence? The terrifying problem is not that we have found clear proof of a civilization before humans. We have not. The terrifying problem is that if one existed far enough back in time, the Earth may have almost completely erased it. Not hidden it. Not buried it neatly for us to uncover. Erased it. That is the part most people underestimate. We imagine the past as something stored beneath us, waiting patiently in layers of soil and stone. We imagine that if something important happened, the planet would preserve it. We imagine history as an archive. But Earth is not an archive. Earth is an engine. It melts, buries, crushes, folds, dissolves, scrapes, floods, burns, and recycles. It takes surfaces that once held forests, rivers, footprints, bones, and perhaps cities, and turns them into sediment. It takes sediment and turns it into rock. It takes rock and drags it into the mantle. It takes the mantle and raises new mountains. It does not care what stood there before. Given enough time, Earth does not preserve civilizations. It digests them. That is why the question of earlier technological life is so difficult. We are not asking whether a pyramid or a machine could survive 10,000 years. We are asking whether any recognizable trace of a technological species could survive 10 million, 50 million, or 100 million years of planetary violence. And the honest answer is uncomfortable. Most of it would not. A civilization can feel permanent from the inside. It can cover continents with roads, lights, dams, ports, satellites, tunnels, power plants, data centers, factories, mines, and cities. It can believe it has become too large to vanish. It can measure itself in steel, concrete, glass, cables, memory, and machines. But geological time is larger than all of that. Steel returns to oxides. Concrete fractures and chemically changes. Glass weathers. Plastics fragment and transform. Buildings collapse. Buried materials are compressed, heated, dissolved, or chemically altered. Coastal cities are drowned, eroded, or buried under shifting sea levels. Oceanic crust carrying evidence is eventually subducted and destroyed. Even if a previous civilization had been global, industrial, and powerful, the odds that one of its recognizable buildings would survive deep time are astonishingly low. This is not because the civilization would have been insignificant. It is because the Earth is too active. Think of the seafloor. Much of Earth's oceanic crust is geologically young compared with the age of the planet. New crust forms at mid-ocean ridges, spreads outward, then eventually sinks into subduction zones. If an earlier civilization built cities on coastlines, continental shelves, islands, or ocean floors, many of those locations would be among the most vulnerable to destruction. And where do civilizations like to build? Near water, near coasts, near rivers, near fertile sediment, near trade routes. Exactly the kinds of places geology likes to rearrange. Now imagine an advanced species that lived not in our current geography, but on continents arranged differently. A species that rose before the Atlantic Ocean opened, or before the Himalayas rose, or before Antarctica froze, or before mammals became dominant. Its cities would have stood under different skies, on different shorelines, beside seas that no longer exist. The map itself would be gone. So even if we searched today, where would we search? The right continent might have moved. The right coast might be underwater. The right basin might be buried beneath kilometers of sediment. The right rocks might have been metamorphosed beyond recognition. The right seafloor might no longer exist. This is the first terrifying limitation. Absence of ruins is not the same as absence of civilization. It may simply mean the ruins were never given a fair chance to survive. But there is a second limitation, and it may be even more disturbing. Natural disasters and artificial signatures can look almost identical after enough time. A civilization that destabilizes climate through energy use might leave a rapid carbon shift. So can massive volcanism. A civilization that triggers ecosystem collapse might leave an extinction layer. So can asteroid impacts, ocean anoxia, methane release, or abrupt climate change. A civilization that mines and redistributes metals might leave unusual concentrations in sediment. So can hydrothermal systems, volcanic ash, impact debris, or later, chemical movement through rocks. A civilization that uses nuclear technology might leave isotope anomalies. So can natural reactors, cosmic ray exposure, rare geological concentrations, or processes we have not yet fully understood. The older the evidence becomes, the harder it is to preserve context. Context is everything. A modern factory is obvious because it sits beside roads, machines, power lines, waste, human remains, written records, and economic systems. But remove the factory, remove the roads, remove the people, remove the machines, remove the language, crush the site into sediment, heat it, alter it, break it apart, spread its chemical signal across a basin. What remains? Maybe a strange enrichment, maybe an isotope ratio, maybe a layer that looks unusual but not impossible. Now ask a scientist millions of years later to prove that it was artificial. Not suggest. Prove. That is the problem. Science is rightfully cautious. It should be. If a natural explanation can account for an anomaly, we should not jump to intelligence. The history of science is full of mysteries that became natural once we learned enough. Lightning was once divine. Fossils were once misunderstood. Continents were once thought fixed. The deep past constantly punishes certainty, but caution has its own shadow. If we assume intelligence is impossible before humans, then every ambiguous signal must be forced into a natural category. Again, most of the time, that will be correct. But the Silurian question asks whether this habit could also blind us to the one case where it is not. That is what makes the hypothesis so quietly dangerous. It does not ask us to believe an ancient civilization existed. It asks whether our methods would be able to recognize one if the evidence no longer looked like civilization. And the answer may not be comforting. Imagine you're studying a rock layer from 100 million years ago. You find a rapid carbon isotope shift, a short warming interval, evidence of ocean stress, unusual metals, a brief decline in biodiversity, some strange organic compounds that may be contamination, may be natural, may be altered remnants of something else. The layer is thin. The signal is real, but not decisive. What do you conclude? You look for volcanism. You look for climate feedbacks. You look for methane. You look for impacts. You look for ocean circulation changes. You look for preservation bias. And you should. But unless the evidence is overwhelming, you probably do not write possible industrial civilization. Not because you are dishonest, because the claim is too extraordinary for the evidence available. And that is exactly why a prior civilization could be difficult to detect. The burden of proof would be enormous. The evidence would be degraded. The natural alternatives would be many. The cultural resistance would be strong. And the planet would have had millions of years to make the signal less clear. This is the terrifying problem of deep time. It does not merely hide evidence. It lowers the confidence of interpretation. It turns certainty into probability. It turns history into chemistry. It turns civilization into a debate. There is also the problem of scale. Human civilization feels planetary today, but geologically it is extremely brief. Our industrial period has lasted only a few centuries. Even if we survive another 10,000 years, that is still a thin pulse on Earth's timeline. Many sedimentary layers represent thousands, tens of thousands, or even hundreds of thousands of years compressed together. A short-lived civilization might appear as a narrow disturbance, blurred by the resolution of the record. If a civilization rose quickly, burned intensely, collapsed rapidly, and left behind only a few thousand years of activity, the signal might be compressed almost beyond recognition. It might not look like a world. It might look like a spike. And spikes are dangerous because they invite multiple explanations. Some spikes are impacts. Some are volcanic episodes. Some are climate shifts. Some are ocean chemistry changes. Some are biological revolutions. Some are artifacts of preservation. Some may be errors. A civilization, if brief enough, could become one more spike among many. Now add another possibility. What if its technology did not resemble ours? We assume industrial civilization means fossil fuels, plastics, steel, concrete, nuclear isotopes, and radio transmissions, because that is our path. But another intelligent species could take a different path. It might rely heavily on biotechnology, or ceramics, or geothermal systems, or ocean chemistry, or materials designed to return harmlessly to the environment. It might build downward instead of upward, underwater instead of on land, biologically instead of mechanically. Its signature might not be the one we are trained to see. If it never burned fossil fuels at scale, there may be no obvious carbon pulse. If it never used plastics like ours, there may be no plastic horizon. If it avoided nuclear technology, there may be no artificial radionuclide layer. If it built with materials that decay cleanly, its physical remains might disappear almost entirely. A sustainable civilization may be nearly invisible. A destructive civilization may be easier to find. That is an unsettling reversal. The civilizations most likely to be preserved may be the ones that failed badly enough to scar the planet. And perhaps that should make us think differently about our own legacy. Because we are leaving a loud trace. We are changing the carbon cycle. We are redistributing metals. We are creating synthetic compounds. We are spreading microplastics. We are altering nitrogen and phosphorus flows. We are driving extinctions. We have created radioactive markers. Future geologists, if they exist, may detect us more easily because of our damage than because of our achievements. They may not find Shakespeare. They may not find Beethoven. They may not find the internet. They may not find a photograph of Earth from space. They may find carbon, plastic, metals, bones of vanished species, and a thin layer of radioactive dust. That is what we may become. Not memory, signal, and not even a clear signal unless enough survives. This should make the question of previous civilizations feel less like fantasy and more like a warning about interpretation. We should not rush to fill ancient mysteries with lost empires. That would be careless. But neither should we forget how quickly evidence decays, how much the planet recycles, and how little of any civilization may remain once geology has finished with it. There is another problem. Archaeology and geology are built on surviving evidence. They are powerful disciplines, but they are limited by what remains available to study. We cannot excavate rocks that have been subducted. We cannot read sediments that have eroded away. We cannot analyze artifacts that were chemically destroyed before they could fossilize. The archive is not merely incomplete. It is selectively incomplete. Some environments preserve beautifully. Others preserve almost nothing. A civilization in the wrong place at the wrong time, using the wrong materials, could leave a far weaker trace than a civilization less advanced but more fortunate in preservation. That means the deep past may contain blind spots we cannot fully correct. And this is where the human mind struggles. We want the past to be knowable. We want clean categories. We want to say, this happened, this did not. But deep time often gives us something less satisfying. It gives us partial evidence, competing explanations, damaged records, and probabilities. The terrifying problem is that a question can be meaningful without being answerable. At least not yet. Maybe not ever. Were humans the first technological civilization on Earth? The most honest answer remains, as far as evidence shows, yes. But the deeper answer is less comfortable. If another existed far enough back, proving it would be extraordinarily difficult, and disproving it completely may be impossible. That does not mean we should believe it. It means we should understand the limits of our confidence. The planet is older than our imagination likes to admit. Its surface has been remade again and again. Entire ecosystems have vanished. Climates have changed. Oceans have opened and closed. Rocks have been destroyed. Evidence has been lost forever. We are not reading the full book of Earth. We are reading surviving fragments. And sometimes, when a page is missing, the absence tells us nothing except that the page is gone. This is the deepest unease behind the Silurian question. Not that we have found another civilization, but that Earth could have hosted something remarkable, something intelligent, something powerful, and time could have reduced it to a signature so subtle that we either missed it, misread it, or explained it away. And if that is possible, even in principle, then the past becomes larger than history. It becomes an abyss. In the next part, we reach the deeper realization. The real question is not only whether an earlier civilization existed. The real question is whether we would recognize it if it did. And from there, the mirror turns fully toward us, toward our own future, our own layer in the rocks, and the possibility that one day we too may be mistaken for nothing more than another natural disaster. The deeper question is not simply whether another civilization existed before us. That question is haunting, yes, but it is not the most disturbing one. The more disturbing question is this: would we recognize them if they had? Because recognition is not as simple as discovery. A signal can exist and still be misunderstood. A trace can survive and still be misread. Evidence can sit inside a rock for millions of years, waiting for a mind capable of asking the right question. And if that question never comes, the evidence remains silent. That may be the true terror of deep time. Not that the past is empty, but that it may be speaking in a language we have not learned to hear. We tend to imagine evidence as something that announces itself, a tool shaped by a hand, a wall too straight to be natural, a machine, a skeleton, a carved symbol, a buried city, something impossible to ignore. But a civilization older than the dinosaurs would not necessarily leave evidence that feels like evidence. It might leave carbon. It might leave isotopes. It might leave extinction. It might leave a strange shift in ocean chemistry, a sudden warming event, a pulse of metals, a sediment layer that looks unusual but not impossible. And if we do not expect intelligence that far back, then intelligence may not be part of the explanation we even allow ourselves to consider. That does not mean we should force technology into every mystery. We should not. A gap in knowledge is not proof of a lost world. A strange layer is not a city. A sudden extinction is not a war. Earth is fully capable of creating enormous mysteries without civilization. The planet has always been powerful enough to destroy, transform, and renew itself. But the Silurian question remains because it exposes a weakness in our confidence. We do not know Earth's past as completely as we feel we do. We know fragments. In some periods, beautiful fragments. In others, almost nothing. Fossils, where preservation allowed them. Sediments, where they survived. Chemical records, where they were not destroyed. Ice cores only where ice remained. Ocean crust only where it has not yet been recycled into the mantle. The archive is not whole. And because it is not whole, certainty becomes more fragile the farther back we go. Imagine standing before a cliff face. Layer after layer of ancient sediment rises above you. Each band represents time, a seafloor, a river delta, a volcanic ashfall, a climate shift, a biological change. To a geologist, the cliff is readable. It has structure, it has sequence, it has clues. But it is still not the full world. It is what survived. Everything else is gone. The cities that were never buried correctly, the coastlines that eroded, the seafloors that subducted, the materials that dissolved, the records that burned, rotted, fragmented, or chemically transformed. Gone. Not hidden. Gone. And that word matters. Because if a civilization disappears completely enough, it no longer becomes an archaeological problem. It becomes a philosophical one. How do you prove the existence of something whose most meaningful evidence was destroyed by the ordinary functioning of the planet? How do you separate an artificial disturbance from a natural one when both can leave similar scars? How do you recognize intention after intention has been stripped away, leaving only chemistry? The answer may be that sometimes you cannot, and that should humble us. We are used to thinking of ourselves as the great interpreters of Earth's history. We dig, measure, date, classify, compare, model. We reconstruct climates from oxygen isotopes, ancient atmospheres from bubbles in ice, vanished ecosystems from pollen, shells, bones, and sediments. These tools are extraordinary. They are among the greatest achievements of human science. But even extraordinary tools have limits. They cannot restore rocks that no longer exist. They cannot recover context that time has erased. They cannot always tell whether a planetary disturbance was caused by volcanoes, feedback loops, impact, biology, or something else if the surviving evidence has been blurred enough. The deeper realization is that Earth may contain histories that are permanently beyond recovery, not because they are supernatural, because they are too old, too damaged, too chemically altered, too incompletely preserved. And if that is true, then the statement, "we were first," becomes less like a proven fact and more like a working conclusion based on available evidence. A strong conclusion, a reasonable conclusion, but not an invulnerable one. That is the quiet power of the Silurian Hypothesis. It does not overturn science, it sharpens it. It asks what we would expect to find, what we would fail to find, and how carefully we should interpret absence. Because absence is complicated. If you search a room and find no footprints, that may mean nobody entered, or it may mean the floor was cleaned. If you search a beach and find no marks, that may mean no one walked there, or it may mean the tide came in. Earth is the tide. Deep time is the tide, and it has been coming in for billions of years. Now turn the mirror toward us. This is where the question becomes personal, because one day humanity may also become difficult to recognize. It does not feel that way now. We feel loud, permanent, planet-sized. Our cities cover the land. Our satellites orbit overhead. Our signals leave Earth at the speed of light. Our machines dig, burn, melt, fly, compute, and listen. We have touched the moon, sent robots to Mars, launched Voyager beyond the planets, and built instruments that can see galaxies from the childhood of the universe. It feels impossible that all of this could vanish, but it can. Not overnight, perhaps. Not completely in 1,000 years. But over deep time, yes. The internet will not fossilize. Most of our books will not survive. Languages will disappear. Digital records will decay. Buildings will collapse. Satellites will fall or drift dead. Machines will corrode. The names of nations, companies, wars, religions, and individuals will not be written in stone unless stone happens to preserve them, and even then, only for a while. What remains of us may be far less human than we imagine. A carbon pulse, a layer of plastics or their chemical descendants, a spike in industrial metals, a rearrangement of nitrogen and phosphorus, a sudden biodiversity loss, a thin dusting of artificial radionuclides, a strange geological boundary marking the moment one species became a planetary force. That may be us, not the songs, not the faces, not the voices, the layer. This is the most unsettling symmetry in the entire idea. When we ask whether a prior civilization could be hidden in Earth's rocks, we are also asking whether our own civilization will one day be hidden in the same way. Will a future intelligence know we were here? Will it reconstruct us as beings with memory, fear, art, ambition, tenderness, and regret? Or will it see only a disturbance? A short-lived geological anomaly, a sudden planetary fever, a mass extinction event with unusual chemistry. Maybe they will argue about us. One group will say, this was natural, volcanism, methane release, ocean feedback, climate instability. Another will say, no, look at the isotopes, look at the synthetic residues, look at the strange distribution of metals. Something intelligent may have happened here. And perhaps they will never be certain. Imagine that. Humanity reduced to a scientific debate in a world that no longer remembers humans. All our certainty, all our noise, all our achievements, compressed into ambiguity. That is not just frightening, it is clarifying, because it reveals what civilization really is against the scale of Earth. Temporary organization, a pattern in matter that holds for a while, speaks for a while, builds for a while, and then either learns how to endure or becomes part of the sediment. We like to think intelligence separates us from nature, but deep time pulls us back into it. A city is geology waiting to happen. A machine is chemistry in delay. A civilization is a layer that has not yet been buried. And that perspective should change how we see ourselves. Not as owners of Earth's story, but as one brief chapter inside it. Maybe the first technological chapter. Maybe not. But certainly not the final word the planet will ever write. This does not make human life meaningless. If anything, it makes it more urgent, more delicate, more astonishing, because meaning does not require permanence. A song is not meaningless because it ends. A life is not meaningless because it is finite. A civilization is not meaningless because stone and time may someday erase it. But permanence is not guaranteed. Memory must be protected. And if we want to be recognized by the future, we may need to think differently about what we leave behind. Not only more durable records, more responsible signatures. Because the easiest way for a civilization to become visible in the geological record is to damage its planet. That is a terrible kind of immortality. A climate scar is durable. An extinction pulse is durable. Radioactive traces are durable. Pollution can be durable. But wisdom is harder to fossilize. Cooperation is harder to fossilize. Music is harder to fossilize. Kindness leaves almost no mineral signature at all. And yet those may be the things most worth preserving. This is where the Silurian Hypothesis becomes more than a mystery about the past. It becomes a warning about the future. If technological civilizations tend to leave their clearest traces through disruption, then perhaps the question is not only whether we can survive, it is whether we can become detectable for better reasons than catastrophe. Can a civilization learn to leave knowledge rather than scars? Can it build archives that last without poisoning the planet that holds them? Can it become advanced without becoming self-destructive? Can it understand deep time before deep time turns it into evidence? These are not questions about ancient species alone. They are questions about us, because we are currently writing our layer. Every year, more of our activity becomes part of Earth's chemistry. More carbon enters the atmosphere. More plastic enters sediment. More species disappear. More industrial compounds move through water, air, and soil. We are not separate from geology. We are becoming geology in real time. The future rock record is being made now. And the strange thing is that we know it. Unlike most species that have changed Earth, we can see ourselves doing it. Cyanobacteria transformed the atmosphere without understanding oxygen. Plants altered climate without understanding carbon cycles. But humans can measure the disturbance as it happens. We can see the graphs, drill the cores, read the isotopes, watch the satellites, model the futures. We are the first known species on Earth capable of understanding its own geological signature while creating it. That gives us a burden no previous life form carried: awareness. If there were civilizations before us, perhaps this was their test too. Not whether they could build, not whether they could harness energy, not whether they could become powerful, but whether they could recognize in time that power leaves traces and that some traces are warnings. Maybe they failed. Maybe none existed. Maybe Earth's past contains only natural catastrophes, biological revolutions, and the blind creativity of evolution. But either way, the lesson remains. A planet can change suddenly. A civilization can be brief. A trace can outlive the truth that made it. And after enough time, the difference between a natural disaster and an intelligent mistake may become almost impossible to read. That is the climax of this question. Not proof, not certainty, recognition. Would we recognize them? Would they recognize us? And if we know how easily history becomes chemistry, what are we choosing to become? In the final part, we will step back from the evidence and leave the question where it belongs, open, careful, and haunting. We will not claim what cannot be claimed. We will not turn mystery into certainty, but we will look one last time at Earth as an ancient world, an imperfect archive, and perhaps the only place in the universe where intelligence has already learned how fragile its own traces can be. Because one day, millions of years from now, something may study the layer we leave behind. And the question will not be whether we matter to ourselves. The question will be whether anything remains that can prove we were ever more than a sudden change in the rocks. So we return to the question where we began. What if humans were not the first civilization on Earth? After everything we have traced, the missing ruins, the chemical scars, the fragile record, the violence of geology, the strange patterns of extinction and climate, the possibility that technology might survive only as a subtle signal, the question feels different now. It no longer feels like a simple mystery about the past. It feels like a warning about time. Because the deeper we look into Earth's history, the more we realize that the planet does not preserve meaning the way we wish it did. It preserves fragments. It preserves chemistry. It preserves pressure, heat, isotopes, ash, bones, pollen, shells, and layers of sediment. It preserves effects more easily than intentions. A civilization may have dreams. The rock record may only keep its pollution. A species may have language. The sediment may only keep its carbon. A world may have music, grief, love, science, conflict, memory, and fear. But after enough time, all of that may become a narrow band in stone. That is what makes this idea so haunting. Not because we can say another civilization definitely came before us. We cannot. The responsible answer is still that there is no confirmed evidence of a pre-human technological civilization on Earth. No city has been found from deep time. No machine has emerged from a rock layer older than humanity. No artifact has forced science to rewrite the story of intelligence on this planet. But absence is not always simple. That is what deep time teaches. The deeper past is damaged. The archive is incomplete. The surfaces where evidence might once have existed have often been erased. Some rocks were never preserved. Some were buried too deeply. Some were melted. Some were transformed. Some were carried into the mantle and lost forever. So the honest conclusion is not certainty. It is humility. Maybe we were first. Maybe intelligence has only once crossed the threshold into technology on Earth, and we are living inside that one extraordinary moment now. Or maybe there were others so far back, so thoroughly erased, so unlike us in biology and technology, that all they left behind were disturbances we have already classified as natural because we had no reason to imagine anything else. The point is not to believe too quickly. The point is to realize how difficult recognition would be. Because if a civilization is recent, it leaves objects. If it is ancient enough, it leaves patterns. And patterns are harder to judge. A strange carbon shift might be volcanism. A sudden extinction might be climate collapse. An unusual metal layer might be impact debris. A chemical anomaly might be an unknown natural process. A brief global disturbance might be nothing more than Earth behaving like Earth. Or perhaps, in one impossible case, it might be the final echo of intelligence. The terrifying truth is that after enough time, those possibilities may become almost indistinguishable. That does not mean every mystery hides a lost world, but it does mean the past is less complete than our confidence wants it to be. We look backward from a narrow place in time and try to reconstruct a planet billions of years old. We are using brilliant tools, but the evidence has been filtered by survival. What remains is not the whole story. It is the part that endured. And perhaps that should make us gentler with our certainty. There is something lonely about imagining a civilization erase this completely. A species that may have watched its own skies, measured its own stars, feared its own future, believed its cities would last, believed its knowledge would be remembered, believed, perhaps, that it was the first. And then time came, not as a disaster in one day, but as weather, erosion, plate tectonics, burial, ocean chemistry, fire, ice, pressure, silence. 1,000,000 years, 10 million, 100 million, until the world that once meant everything became unreadable. That is the true scale of Earth. It is not only a home, it is an eraser. And yet, somehow, it is also a witness. Because not everything disappears. The planet does keep certain scars. It holds the memory of asteroid impacts, oxygen revolutions, volcanic provinces, ancient oceans, vanished forests, mass extinctions, and climate shocks. It cannot preserve everything, but it preserves enough to tell us that Earth has changed violently before. The question is whether intelligence, if it came before us, would have left a scar distinct enough to survive that process. And we do not know. That uncertainty is where the story must remain. Open, careful, unresolved. Because the mystery is not useful if we turn it into false certainty. The value of the question is not that it proves a lost civilization. The value is that it forces us to think more deeply about evidence, time, and our own fragility. It forces us to ask what it really means to be remembered by a planet. And that is where the mirror returns. Because whether or not there were civilizations before us, there will almost certainly be a record of us. Not a complete record, not the one we would choose, but a record. A thin layer forming now, quietly, beneath our feet and around our oceans. Carbon from buried fuels, plastics in sediment, industrial metals, artificial radionuclides, altered soils, extinction patterns, a planetary chemical signal written by billions of ordinary lives and the systems that support them. We are not just living through history. We are becoming geology. Every factory, every city, every field, every mine, every engine, every landfill, every satellite launch, every forest removed, every species pushed toward disappearance, all of it participates in the writing of a future layer. And someday, if there is anyone left to read it, they may ask about us. They may not find our faces. They may not hear our voices. They may not know the names of our children, our songs, our countries, our gods, our fears, or our hopes. They may only find the disturbance. And they may wonder, was this natural? Was this an accident of climate? Was this volcanic? Was this biological? Or did something know what it was doing? That is a brutal thought, because from the inside, civilization feels full of meaning. Every life is enormous to the one living it. Every city contains millions of private worlds. Every age believes its questions are urgent, its conflicts decisive, its achievements permanent. But from deep time, all of that may become almost invisible. A whisper in stone, a chemical hesitation, a boundary layer. And maybe that is why the Silurian question matters, even if the answer is no. Even if humans are the first and only technological civilization Earth has ever produced, the question still teaches us what we are up against. It reminds us that intelligence does not automatically become permanent. It reminds us that technology does not exempt a species from geology. It reminds us that being loud in the present is not the same as being legible in the future. To endure, a civilization must do more than build. It must learn how to be remembered. And perhaps more importantly, it must learn how to survive without leaving only damage as proof. Because the easiest traces to preserve are often the worst ones. Pollution survives. Extinction survives. Radiation survives. Climate disruption survives. Chemical scars survive. But wisdom, kindness, music, the quiet miracle of a species learning not to destroy itself, those are harder to fossilize. So, if we want the future to know us, maybe the question is not only what we leave behind, but what kind of trace we are willing to become. Do we become a warning, a brief industrial fever, a species that altered the planet quickly and vanished before it understood the cost? Or do we become something rarer, a civilization that noticed its own geological power and changed course before its clearest legacy became damage? That may be the real test. Not whether we can prove there were others, but whether we can learn from the possibility. Maybe another civilization did once rise here and fail. Maybe no one did. Maybe the rocks contain only natural catastrophes, biological revolutions, and the enormous unfinished story of Earth becoming itself. But either way, we know enough to understand this. Planets can change. Civilizations can vanish. Evidence can fade. And a species can mistake its moment for permanence. We should be careful with that mistake. Because one day, the continents will look different. The oceans will shift. The cities we know may be gone. The languages we speak may no longer exist. Even the stars in the night sky will slowly rearrange as the galaxy moves. Time will make strangers of everything familiar. And somewhere in that distant future, perhaps a mind will dig into an ancient layer and find the faintest trace of us. A carbon anomaly, a plastic residue, a burst of radioactive isotopes, a sudden silence in the fossil record. Maybe they will understand. Maybe they will say, there was a civilization here. Maybe they will imagine our lights, our machines, our voices, our loneliness, our questions. Or maybe they will mistake us for weather, for chemistry, for another natural disaster. And that is where this journey has to end, not with an answer, but with a question large enough to remain open. If another civilization studies Earth millions of years from now, will they know we were here? Or will we be nothing more than a strange layer in the rocks, waiting for someone to wonder what happened?